Section 4.1 has to do with polynomial functions. Specifically, we're going to talk about polynomials with one variable. In other words, one letter. This is not a polynomial in one variable because I have an x and a y and a z. This one, however, is because all I have is different powers of x. So that is a polynomial in one variable. And that is, for the most part, what we're going to be talking about in this chapter. Just a refresher here on some of the terminology. What is the degree of this polynomial? We need to find out what the degree is. So if you remember right, you find the largest power that you have. So the degree of this polynomial is 3 because the term is 2. The degree of that term is 2, the degree of that term is 1, and the degree of that term is 0. So the degree of this polynomial would be 3. If they ask me for the leading coefficient, I'm looking for the number that is in front of the exponent, the base with the exponent of the highest degree. So the leading coefficient on this is 1 because I have understood 1 in front of x to the third. I'm going to determine whether 4 is a 0 of this polynomial. Well, in order to do that, I have to understand what 0 roots or solutions are. They are often used interchangeably, even though they do mean different things. But it is where this equation is going to cross the x-axis. The 0 of this polynomial is where it crosses. The solution of this polynomial would be what makes this true. So to find out if 4 is a 0 of this polynomial, well, actually I've got space. I'm going to do that on the other page. And then we need to understand there could be real or imaginary roots. So they group them in a category called complex. Real is basically all our numbers except for imaginary numbers. Complex would be both real and imaginary. So let's really work on this. Let's see if 4 is a 0 root or solution of this. The way that I find out is I plug the 4 in for the x. If I get a 0, that means that 4 is a 0 root or solution of that polynomial. So remember, I'm going to take the 4, I'm going to store it for x, and then I'll put the equation in. So don't forget how to put that into your calculator. So let's do it real quick. And it does give me a 0. So I know that 4 is a 0 of this equation. So if you graph this equation, it would cross the x at 4. So I don't have to know anything about the graph, but I know it's going to cross right there. Now I don't know what all else it does, but I know it crosses or hits the x-axis right there at 4. The fundamental theory of algebra says that every polynomial with a degree greater than 0 has at least one complex root. Now, if I come back here, the degree of this polynomial is 3, so it has 3 complex roots. They might be real, they might be imaginary, they might be rational, they might be irrational, but there's 3 complex roots. Every polynomial can be written as a product of its factors so that a polynomial with a degree of n has n complex factors. So if I went and let's say I factored something. I would know this has 2 complex roots. I can write it as a product of x plus 2 and x plus 2. Okay, so that's if it has n roots, which is 2 in this case, you should have 2 parentheses here that you can multiply together to get that. An odd degree must cross at least once. So if you remember anything about an odd number, the end behavior goes in opposite directions. So no matter where I shift this thing, eventually I could shift the whole thing down. So this has 1, but it might have more than 1. It might do this. It has 3 roots. It might have 5 roots. It might have 7. Okay? But it's going to have at least 1, because if I shifted this whole thing down where it doesn't cross, when you continue that arrow up, it's going to cross 1 time. So an odd degree would have actually an odd number of complex roots. An even degree, if you remember right, the end behavior always goes in the same direction. But let's say I had that parabola that's above the line. It has 0 complex roots because it never, well, it has 0 real roots. It might have 2 complex roots, but they don't necessarily cross the line. Let's say I have this one. It's going to cross 1, 2, 3, 4, 5, 6 times. So it has 6 real roots. So the real roots are where it actually crosses. But the complex roots are a combination of real and imaginary. Obviously the imaginary ones, they don't cross the x-axis with. So you'll be able to look at any sort of polynomial in one variable, which is this one, and I can tell you how many complex roots there are. So if I have this, I find the degree, which is the highest exponent. So the degree of this is 4. Its leading coefficient, so leading coefficient is 3. Okay? How many complex roots does it have? Complex means both real and imaginary. Well, so y'all do what, you know what imaginary, so you're talking like i's or 3i or 3 plus 2i. So when I think of imaginary numbers, I always think of i's. Okay, so how many complex roots does it have? Well, it's going to be the same as the degree. It has 4 complex roots. It might not cross the x-axis 4 times, but it has 4 complex roots. It is actually going to cross the x-axis 4, 2, or 0 times. You always count back by 2. So now it's asking me how many real roots it has. In order to do that, I would have to factor this thing. I wasn't thinking that there was 5. I think I might have written that down wrong. In the future, and this whole chapter is about this, is we're going to find our way to factor this thing with a way that you know how to factor it. I'm just surprised that I have that all in there like that. Let me look at the book real quick. They didn't actually, okay, on that one they didn't want you to find the number of real roots. You could find that by looking at the calculator, but so they're going to give you, normally it's going to be a 4 or it's going to be something that you know how to factor. But they do ask you this question. Determine whether -2 is a 0. So what I'm going to do is I'm going to plug in -2 into this equation. If I get 0 as a result, I know it's an actual factor. So I'm going to store it for x, and then I'll put my equation in. And it gives me 59. So the answer here is no. -2 is not a 0 of this function. Okay? So now we're going to go backwards. They're going to, rather than give us the equation, they're going to give us the roots of the equation, and we have to work backwards to find the equation. So if these are the roots, then that means I had to get them from a factor. So if I have x minus 2 and I set that equal to 0, my solution would be 2. So this is how I'm going to write them as factors. So I have x minus 2, I have x minus 4i, and I have x minus a negative 4i, which ends up being x plus 4i. Notice these are differences of squares. So basically, I have to do Florida on that, first and last. So I have x minus 2, and I have x squared minus 16i squared. But I can never have an I squared left in my problem. I squared is equal to -1. So this is x minus 2 times x squared plus 16. Now I have to do FOIL on this. So I have x cubed plus 16x minus 2x squared minus 32. If I put it in order, I have x cubed minus 2x squared plus 16x minus 32. So that is the polynomial that has these as the roots. Now notice, see it had a 3 here, so we knew it had 3 complex roots. We have 1 real root and 2 imaginary roots, but that gives me the 3 roots. Another example, they give me these as my roots, so I'm going to write it as x minus 2, x minus 3i, and if you will, you have an x minus a negative 3i, which is an x plus 3i. Just have to do Florida on that. So I have x minus 2 times x squared minus 9i squared. But the I squared is a -1, so this is x minus 2 times x squared plus 9. So FOIL is going to give me x cubed plus 9x minus 2x squared minus 18. If I write it in the correct order, I have x cubed minus 2x squared plus 9x minus 18. I look at this. Does this equation have an odd or an even degree? It has an odd degree, so I know it's going to have 3 or 1 real roots, and that's really all I know, except for the fact that they had already given me the factors. So I have 1 real root, so it's going to cross 1 time, and then I have 2 imaginary roots. Okay, so the 3 told me I have 3 roots, 2, 3i, and -3i. It has an odd degree, so I knew it was going to have a 3 or a 1 real root. And it has 1 real root and 2 imaginary, so it crosses the x-axis 1 time. All right, state the number of complex, that should be of, complex roots of this. They are, there's 4 complex roots. I don't know if they're real or they're imaginary. This is one I should be able to break down because it has 3 terms. So I'm going to break this into 2 different parts. Let's see. I would bet I have a 4, a 1, a 9x squared, and an x squared. Remember, this times this has to give me this. This times this has to give me that. Outside plus inside has to give me this. So if I have a negative 36x squared and a positive x squared, it's going to give me that negative 35. If I set these equal to 0 and solve them, I have 9x squared plus 1 equals 0. So I have x squared is equal to negative 1/9. If I take the square root, notice that I am taking the square root of a negative, which means I have plus or minus 1/3i. So positive 1/3 I, negative 1/3 I. So that's 2 roots. I could write them as 1/3 I and negative 1/3 I. 2 imaginary numbers. This one, I have x squared is equal to 4, or x is equal to plus or minus 2, because the square root of 4 is 2. So that gives me 2 more solutions, or 2 more roots, a positive 2 and a negative 2. So these are all my roots. I knew there was 4 of them. There's 2 imaginary and 2 real. So this thing crosses the x-axis 2 times. It crosses it at 2 and it crosses it at negative 2. This is another one. Because it has 4, I can do grouping on it, if you remember how to do grouping. So I'm going to factor out what they have in common, which is a 32x squared. It leaves me with x minus 1. And this one I'm going to factor out of 4, and it leaves me with x minus 1. So I take the parenthesis that they have in common, factor it out, and then I put what's left in the other parenthesis. Now if you notice, I can factor out of 4 here, so I can go 4 times x minus 1 is going to give me an 8x squared plus 1. Okay, equals 0. I can get rid of the 4 because I factored a 4 out of that. So if I divide both by 4, that goes away, and I'm left with x minus 1, 8x squared plus 1. They both equal to 0, so when I set x minus 1 equals 0, I get x is equal to 1. When I set 8x squared plus 1 equals 0, I've got a x squared is equal to a negative 1/8. I'm going to take the square root of that. So I have, and it doesn't come out whole, so I actually would have to rationalize the denominator there. So when I take the square root, on the bottom I have 2 on the square root of 2. So I can call, and so I'm going to go the square root of 2 over the square root of 2. Okay, so I have got plus or minus square root of 2 over 4i. Okay, so that's going to give me my 3 roots. So I've got 1, I've got square root of 2 over 4i, and I have got the square root of 2 over 4i, but it's negative. So 1, 2, 3, 3 roots. 2 of them are imaginary and 1 of them is real. So this thing crosses the x-axis 1 time. Hopefully you can see all that. You'll get better and better at these the more we work on them. Your homework is page 210 through 211, 15 through 47 odd. So the answers are in the back of your book.